When simplifying a radical, what we're trying to do is we're trying to take any perfect squares out of our radical to make it as simple as possible. There's two ways we could do this. The first way is we could take our square root of 28 and we could break it into a product with a perfect square in it. So a perfect square that divides into 28 is 4. So we could rewrite that as the square root of 4 times 7. Now since we know the square root of 4 is 2, we could pull that 2 out to the outside and we are left with a root 7 on the inside. Now another way we could do this is we could take our 28 and we could break it into a product of our prime factors. So we've got two 2's and a 7. 2 times 2 times 7 is going to give you 28. Because it's a square root, we're looking for groups of 2. So there's a group of 2 right here. When I take the square root of that group of 2, I'm going to get 2. And I have a remaining 7 that didn't have a partner. So I get 2 root 7. Now if I'm dealing with a fraction, I do the same thing except for I treat each numerator and denominator individually. So 40, I'm just going to write up here, is a product of 2 times 2 times 2 times 5. And 81 is 3 times 3 times 3 times 3. So now what I'm going to do, because it's a cube root, I'm going to look for groups of 3. So I can pull out 2's and I can pull out 3's. So the 2's come to the outside, the 3's come to the outside, and left on the inside that didn't have a partner, I'm left with the 5 and the 3. So the math isn't any different. You just sort of treat the numerator and denominator separately. The answer to your numerator goes on the top spot, and the answer to your denominator goes on the bottom spot. Now we have to look at which values of variables are going to be undefined. Now in order for something to be undefined, what we're looking for is we're looking for a square root or a fourth root or a sixth root or some kind of even root to be equal to something less than 0, because you cannot take the square root of a negative number. So in this first example, I've got the square root of 54x to the third. If I need this to be positive, so the x value must be positive, we can indicate that by saying x must be greater than or equal to 0. And that only really concerns us when we have an even-numbered root. In the second example, because our exponent is an odd number, our x value can be positive or negative. So we can write that as x can be all real numbers. So if you've got an even-numbered exponent, you do need to look and see if your x value is inside, and if it is, you need to make sure that that value is going to be positive. If it's an odd-numbered exponent, we don't care. X could be any real number, because it could be a positive or a negative value. Finally, simplifying with variables in it. So we're going to break these up the same way as we did before. If we break up 75, we get 3 times 5 times 5, and if we break up the a squared, we get a times a. So now I'm looking for things I can pull out. I've got a pair of 5's, so the square root of those is going to be just a 5. I've got a pair of a's, so that's going to come out, and what's left on the inside is going to be a square root of 3. Now you'll notice I have no variable inside my root, which means I have no restrictions on my variable. Now moving over here, I could do this using perfect squares as well, so I could say that this is 2 times 9, and then I have 5 b's. Square root of 9 is going to come out because that's going to give me 3. I've got a pair here and a pair here, so I'm going to have 2 that are going to come out. I'm going to get b squared. And what's left inside is going to give me 2b. Now here I do have a variable inside my radical. My radical is an even number, so I do need to make sure that I indicate that b must be greater than or equal to 0. In my next example, I've got a cube root of 15x. So my cube root is negative, and then if I break it down, it's 3 times 5 times x. Well, there's no perfect cubes that I can pull out of this, so it's going to remain the same, but if I want to, I can pull out my negative, and I'm going to be left with the cube root of 15x. Now remember, x is a cube root, it can be negative, so we're not worried about what the value of x is. We don't need to define our restrictions. And finally, the fourth root of 80, I can break down into 2 times 2 times 2 times 2 times 5, and then 7e's. So there's my 7e's. Now it is a fourth root, so I'm going to look for a group of 4. There's one group of 4. There's another group of 4. So a 2 can come to the outside, an e can come to the outside, and left on the inside I've got 5, and I've got 3 e's left, so it's going to become e to the third. Now a fourth root is an even numbered root, which means I do need to define that e must be positive, or e must be greater than or equal to 0.